You ever wonder why this happens? You start off with this brilliant, clean idea, but somewhere down the line, it just gets messy, tangled, inefficient. It's a super common story in the software world. So what's the secret culprit here?
Well, it really is this simple. They forget the blueprint. Think about it. You would never, ever try to build a skyscraper without a detailed plan, right? You can't build solid software on a shaky foundation either. Without that blueprint, you're pretty much just guessing your way through it.
And that blueprint, it's got a name, high-level design, or HLD for short. So today, we're going to break down exactly what that is, why it's so incredibly important, and how you can create one that really sets your project up for success right from the get-go. First up, let's talk about when this all happens.
Right. The most important work actually begins way before anyone writes a single line of code. This is the architectural phase. This is where we lay the groundwork for literally everything that comes after.
And look, this is not just a nice-to-have. As this quote says, it's paramount. The HLD is the master plan. It dictates the structure, the behavior, and ultimately the success of the entire system. It's where you win or lose the game before it's even started.
Okay, so what exactly is in this blueprint? What does it actually contain? Let's dive into the anatomy of a really solid high-level design.
The best way to think about it is like a satellite map of your software. It gives you that critical bird's-eye view. You're not seeing the individual street signs or houses. Those are the tiny implementation details. Instead, you see the major districts, the main highways connecting them, the whole layout of the city. It's a strategic guide, not a tactical step-by-step manual.
And this map is really defined by three key things. First, you've got the system architecture. That's the skeleton, right? The core structure holding it all together. Then you've got data flow diagrams. Think of those as the circulatory system, showing how all the information is going to move around. And finally, you have the modules. These are like the individual organs, each with its own specific, vital job to do. When you put them all together, you get a complete picture of the living, breathing system you're about to build.
So, now we know what an HLD is. But what separates a decent plan from a truly great one? Well, a great design rests on three foundational pillars. These are the things that make sure your system isn't just functional, but also robust and ready for the future.
Our first pillar is modularity. The idea here is simple, but it is so powerful. Don't build a monolith, build with Legos. You want to create a system out of these distinct, independent parts that you can develop, test, and maintain all on their own.
And how do you do that? Well, a few key ways. You define really clear interfaces so each block knows exactly how to connect to the others. You also encapsulate functionality, which basically means each block just minds its own business and doesn't expose all its inner workings. This is what makes them interchangeable. If one piece isn't working or you need to upgrade it, you can just swap it out without wrecking the whole thing.
All right, next up is Pillar 2, Scalability. This is all about planning for success. Your system might serve 100 users today, but what happens when it's 10,000 or 1,000,000? A truly scalable design says, yeah, no problem.
The key is to be proactive about this stuff, not reactive. You plan for load balancing right from the start to avoid bottlenecks later. You choose scalable technologies from day one. Things like cloud services are perfect for this. And you implement caching to keep the data people need most right at their fingertips, which makes everything feel way faster. It's not about reacting to growth, it's about designing for it.
And that brings us to our third and final pillar, and this one is absolutely non-negotiable: security. In today's world, security can't be an afterthought. It can't be a feature you tack on at the end. It has to be woven into the very fabric of your design from moment one.
So what does that mean? It means adopting a security-first mindset, where every single design decision gets viewed through a security lens. It means using established security patterns to defend against the usual threats, and maybe most importantly, planning for secure data flows. You have to assume every piece of data is sensitive and protect it with encryption, both when it's just sitting there and especially when it's moving around.
Okay, so you've created this brilliant blueprint. It's built on our three pillars. Now what? Do you just file it away and forget about it? No way. A high-level design is not a static document. It's a living, breathing one.
And the difference is huge. A static design is rigid. It's a fossil. It becomes a historical artifact almost immediately. But a living design? It's adaptable. It evolves as new requirements pop up, and it actually embraces feedback. That's what keeps it relevant and useful through the project's entire life.
To make this happen, you've got to build some new habits. You start conducting periodic reviews to make sure the blueprint still matches the reality on the ground. You embrace iterative development, which lets the design evolve in small, safe cycles instead of forcing these massive, risky overhauls. And, crucially, you maintain detailed change logs. This creates a history that is just vital for understanding why decisions were made down the road.
So, if there's one thing to take away from all this, it's this. A great high-level design is so much more than a document you make at the beginning. It's the active guiding philosophy of the project. It is the architectural foundation that ensures what you built isn't just functional today, but that it's robust, scalable, and secure enough for whatever tomorrow throws at it.
And that kind of leaves us with one last thing to think about. Is that perfect design something you create at the very beginning and then just execute? Or is the real perfect design the one that's smart enough and flexible enough to adapt and evolve over time? Something to chew on.